Hello, everyone. Welcome to Luohan Webinar. Today, we are very happy to have Dr. James Brand from Microsoft. So recently, large language models have received huge attention as a technology that can be applied across various domains, which has the potential to significantly enhance labor productivity. However, our insights on how exactly the large language model can augment labor still remain limited. So today, we are very happy to have very happy to have Dr. James Brand from Microsoft, who will provide valuable insights on the possible uses and limitations of the large language models in the field of marketing research and practice. James Brand is a senior researcher of Microsoft in the Office of the Chief Economist. His research interests include industrial organization and applied econometrics. His recent work has focused on the estimation of demand and production functions. He earned his PhD in economics from the University of Texas at Austin in 2021. Today, he's going to talk about his paper using GPT for market research. And just before start, just friendly reminder that we prefer display of your name and institution to make the better discussion in the internet forum. And then floor is yours, James, and we have 1 hour.
Okay, great. Thanks a lot for having me. I'm really excited to hear what people think about this paper. This is my first time presenting it, so it'll be a fun, well, it's mostly my first time presenting it, so it'll be a fun learning experience for all of us. It's a fun paper that is unlike most of the economics papers I present, in that it doesn't really have a model, and it doesn't have very much theory. And so the nice thing is that we're going to get into results pretty quickly. So feel free to kind of interrupt me if you have questions, and we can always kind of skip some subset of results pretty easily. So let me dive in. The title of the paper is Using GPT for Market Research. And so, a nice place to start is kind of, what is GPT? For anyone who's not familiar at this point, at least for a lot of people, I think it looks something like this. And so here's a nice, fun little video, right? So a lot of people have interacted with this chat GPT, which is, a place where you can go and you can type in a question like, explain what is market research? And it'll come up with this very, in general, kind of long-winded question. Market research is the process of collecting and analyzing information, blah, blah, blah. So you can read as much of it or as little of this as you want, but this is kind of one of the things that, this is the main way that people have, I think, in my experience, been familiar with what GPT is. It's a place where you give it a question and it gives you an answer back. But more generally, GPT is part of this kind of larger wave of generative artificial intelligence, which has kind of taken over the past 6 to 12 months. And slightly more specifically, it's a large language model. Complex text-based models, which are just trained on huge amounts of text data and are basically targeted at generating, at taking a given set of text and trying to predict what the most likely next set of words would be. So a good example of this is something like Gmail's sentence completion, where you've given it some part of a sentence and it tries to guess what the next word should be. This has already been applied to a huge number of applications, including translation between various languages, coding. GitHub Copilot is fantastic if you haven't used it, and now both Google and Bing or Microsoft have search components that have large language models incorporated. So GPT is just one of these large language models, but it is one of the most popular, and so that's what we're going to talk about mostly today. So there's already some academic work which has started using GPT, and a handful of components, and the two that I'll highlight today are that there's some work showing that GPT is actually productivity enhancing in a couple of different contexts. So one is, there's a Copilot experiment run by Sita Peng, who's one of my colleagues at Microsoft, showing that the speed of programmers increased by 55% when they were augmented by Copilot. There's also been work recently showing that ChatGPT helped users write faster when they were performing professional writing tasks. And then in a sort of separate literature that I find just super fascinating for economists, there's some work by Argyle et al. And by John Horton who have shown that you can use the fact that these tools are so focused on generating reasonable kind of text that looks like what a person would say. You can use that fact actually to generate responses to either political in the case of Argyle et al., or economic in the case of John Horton's paper, circumstances. And so you can use that to kind of simulate human behavior, or at least human verbal behavior, if you will. And so I think our paper is kind of coming at what I view as the intersection of those two questions. So we're interested in kind of using GPT to simulate customers, consistent with this kind of the second section of papers that I discussed, but in a way that we're hopeful will be like labor hunting for market similar flavors of researchers. And the way we're going to kind of operationalize this high level question of can GPT be used for market research is via these two sub questions. So the first component that we focus on is basically, are GPT's responses even broadly aligned with what we think of as fundamental properties of consumer demand, by which we mean something like appropriately defined, are GPT's demand curves downward sloping? If GPT is made to feel richer, is it going to have shallower demand curves, which is also predicted by economic theory, and a couple of other tests that we run. And then supposing that GPT passes at least some of those tests, the second question that we try to tackle is, okay, supposing, okay, it's great that it acts sort of like a customer. It can provide some responses that are somewhat intuitive. But the question is, if I actually want to learn something about in real world empirical facts, are the estimates that I get, say from economic models using data generated from GPT, going to actually be realistic and meaningful in the sense that they line up somewhat reasonably with what we would get if we actually asked real customers? So what we try to do to answer these questions more narrowly is like focus on substituting in GPT instead of the traditional workflow that market researchers would go through. So in general, if you're trying to do some sort of market research for, say, a new product, you'd collect a focus group or some set of customers that you need to sort of randomly select. You need to survey them. It's very cost intensive to design the surveys that you're going to give those customers and even to find them, and you have to pay them. And there's all kinds of constraints that make this somewhat challenging to do. And so what we're asking is essentially, can we just plug in GPT into that step? And rather than collecting customers, let's use GPT to generate the same survey responses that a market researcher otherwise would have had to collect from tens, dozens, hundreds, thousands of humans, depending on the size of the study. And essentially what we're going to do is ask GPT to simulate a random sample of customers. So it's kind of right out of the box. I'm kind of highlighting the simplicity here. We're just taking exactly what we would have tried to do with real people doing with GPT. We're going to query GPT hundreds of times. Unlike most people's interaction with the chat interface, where you kind of ask it, what is market research, and it tells you an answer, we're going to ask it a question. We're going to tell it, please respond, maximizing the randomness of your output, and then we're going to ask it, 300 times for every question that we ask it, so that we can kind of learn what's the full distribution of responses it might have given. And our hope is that because GPT is a large language model, which was trained on huge amounts of internet data, which is likely to contain things like product reviews, blogs, anything that mentions product attributes and customer preferences, our hope is that these seemingly random responses that GPT gives actually contain some of the underlying preferences of the customers that generated the data on which it was trained. So that's the goal here. So to give you kind of an explicit sense for the way that we think about this survey, what we do is we ask GPT to fill in a survey question, or the response to a survey question, as if it were a randomly selected customer. So we just tell it a customer is shopping in the grocery store, they're randomly selected, they see these products on the shelf, and then we ask it either what would you pay for these products, or which of the products would you choose? Okay, so it's as simple as that. And that's going to be our version of a survey. Okay, and then to dive into exactly the studies that we're going to use to answer the questions that I outlined a few slides ago, we're going to, the fundamental properties of consumer demand are the ones that we decided were fundamental. Of course, there's a bunch of others that you could test. The ones we tested are, first of all, whether GPT's responses are generate downward sloping demand curves. Second, whether GPT, if endowed with more income, has shallower demand curves. So essentially, whether the marginal utility of wealth is diminishing, as we predict from economic theory. Third, whether there's state dependence, by which we really just mean in this context, serial correlation of purchases. So if I tell GPT that the customer bought product 1 last time, does it know that GPT should ability of consumption? And then when we get to realism, the focus of our study will be on willingness to pay. So first we'll focus on willingness to pay for products. So namely, if I just describe a product to you or describe a product category to you, can GPT actually provide willingnesses to pay for that product that are sort of consistent with the prices we actually see in practice? And then second, if I actually just think about comparing two individual products, that differ on a single attribute, can GPT generate a willingness to pay for the valuable attribute that's consistent with human surveys and or intuition and other things? So we'll go through all 6 of these, assuming that we have time.
I have a small question. So here, did you guys fit into additional data into this model? For example, additional like specific data from the consumers, like.
Right. No, and I think that's kind of the thing that's amazing about some of the results that I'll show you. There's no fine tuning here or anything like that. I think that is something that is possible and is certainly an interesting path forward, but we do not do any kind of fine tuning with GPT-3.
Okay.
So this will, become clearer, and I hope there will be, potentially lots of questions when we. Is there? I see that there's a hand raised. Feel free to jump in if there's a question.
So I do have a question on this. Do you have any sense, given this research, how stable these attributes will be? In 6 months, will these answers be different? To give you a quick example, I know a colleague that put together a study of whether or not ChatGPT could pass the bar exam. It did so at the 10% level, and 6 months later, it did so at the 90% level. So I'm wondering how stable the responses might be even 6 months from now.
I think that's an interesting question. It's certainly one that we think about. I think it could go either way, to be honest. There's a sense in which these large language models are changing. There are also many large language models now that are available, and so the results may differ across them. So there's at that point towards was there? Okay, sorry, maybe it was an echo. I tend to think of the problem as also from the other direction, which is that a lot of times we care about market research, which is kind of very, very up to date. We may care about conducting market research annually, but they probably will not train kind of huge foundational large language models every year. And so actually thinking about how should I go about using these tools, but in a way that can also live update as the world changes when the models don't necessarily change, I think is a complicated question. So in both directions, I think it's worth thinking about, but I don't have an answer yet. So if that answered that, the first thing that we asked GPT is, can it generate a downward sloping demand curve? So we're going to do that we're going to explore that in 2 ways. One is if I give GPT a binary choice. So there's going to be one product, it's going to be a laptop in our case. And we'll just ask it, do you want the laptop or not? And then we'll raise the price and we'll ask it, do you want the laptop or not again? And we'll check to see kind of if we raise the price, is it less likely to choose the laptop? And then second, we'll give it a second good and we'll allow it to choose among multiple alternatives and ask kind of the same question. So here's exactly the prompt that I believe we gave for a binary choice. If it's not exactly the one that's in the paper, it's very, very similar. We included all of our prompts in the paper. And the gist is, as I said, we tell it that there's a randomly selected customer. We provide an annual income just to give it a sense for how price sensitive this customer should be. And we describe a product in detail. And as you can see, we kind of capitalize and highlight price to show that this is the value that we're going to change when we submit these prompts. So we'll submit the prompt multiple times, one for every value of price from $750 up to $1250. And then the customers asked when they finished shopping, did you purchase any laptop? And if so, which one? This, I know it's kind of odd phrasing here at the end. This is sort of to be consistent with some later prompts, but it doesn't really matter if you ask this in a more natural way, like, did you purchase the laptop? And just for fun, I really like showing these responses that it gives. So, obviously, this is just a text model, right? So these are not actual people, but the response it gives are kind of things that I imagine. And he says, I didn't purchase any laptop. I was looking at the Surface Laptop 3, but I wasn't convinced it was a good value considering its specs. It's a fully coherent answer. And so I think that's kind of encouraging or exciting that maybe, it can generate answers that at least seem intuitively like something that a person could have said. And so then we take all of these, we condense them into this yes, no, binary variable, we aggregate them, and for every price, we calculate how often did GPT decide to purchase the laptop. So that'll let us trace out a demand curve, and here it is. And to my knowledge, this is the first demand curve estimated with GPT. So this was very exciting for us when we found this. And so what we're plotting here, as I mentioned, is the fraction of I'll say customers when I mean GPT responses, the fraction of customers that chose to purchase the laptop as a function of the price of the laptop. And so as we increase the price, the fraction of customers that buy the laptop decreases, I'll say generally, so it's not perfect, it's not monotonic. There are certainly some bumps here, but I also think there's a clear downward trajectory in general. And so this was kind of very exciting as a first result. We then, and for a lot of our prompts, are going to have two goods for the for the GPT to choose between. And that's partly just because this is sort of what people do in practice when they're doing market research. There's often two products that you want customers to choose between. And it's also because we found that things sort of behave differently in notable ways that we should explore when we give it a reference price. So before, we were only including laptop 3, and there was sort of no price to kind of pin anything to, no price to respond to. But when we made a second price that it could choose other than the price we give it, you'll see that the behavior is somewhat different. Other than that, the prompt is, I believe, exactly the same as the previous. So the next is this new demand curve. And so I think, here we've got I'll say a very demand curve, it's bumpy, I think. There's the dotted line in any of the figures I show you with a dotted line is the price of the second good that's not shown here. So this was a MacBook. And I think that this is pretty intuitive. I suspect that customers behave this way as well. But in general, I think the demand curve is still downward sloping. So far, so good. GPT has kind of passed our first test of, it seems to be price sensitive. And I'll note for anyone interested in doing this on their own, just to back up a slide, that something that I find very, very cool is that the slope of these demand curves actually varies depending on the identities of the goods that you give it here. So you can actually, it does know things about these brands, and you can get uglier or prettier demand curves depending on the brands that you substitute in. So I find that to be a really fascinating feature.
I have a small questions. So did you also try to do the same experiment with a non-existent, like, imaginary product?
Right. So in the paper we don't, because it's kind of I don't know, maybe Pandora's box, some sort of metaphor there. There's so many ways you can go with new products. We have done some kind of offline tests with that, where we combine things that don't exist, or things that didn't exist when the training was done for GPT-3, which is the LLM we use here. And we found that it seems to do kind of reasonably, but that's something that I think we're still working on formalizing.
Oh, okay, yeah, super interesting. Thank you.
Okay, so the second of our kind of fundamental economic features that we wanted to test is what the impact of income on GPT's choice was. And so what we're going to do here now is we're taking the same prompt that we had before, but in addition to price varying from $750 to $1,250, we're also going to change income. So we're going to tell GPT in one case that the customer has $50,000 of annual income. And in the second case, we're going to tell GPT that the customer has $120,000 of annual income. And economic theory suggests, and certainly empirical evidence suggests, that richer real human customers should be less price sensitive. So we should find that it should be less sensitive to significant increases in the price. And on the next slide, I'll show you whether that was true. And thankfully for us, it does seem to be true. So what we are showing here is in red, we're showing and for anyone who's colorblind, this is the first, the top graph. This is the $50,000 income demand curve. And as you can see there, it's pretty close to the $70,000 demand curve that we showed before. And then in blue, this shallower line is what happens when we tell GPT that it has $120,000 annual income. And now this is, I think, a kind of an odd demand curve in some ways. It actually looks like it's totally flat for this customer until the price of the reference good, and then it's totally flat again after kind of a steep drop. But as I mentioned before, you can actually get quite different responses depending on the identities of the products. And so we show in the appendix that you can get kind of nicer, smoother, downward sloping demand curves if you ask about different products, which again, I think was quite a shock to me. Okay, so that's test number 2, that that income seems to impact GPT's responses in ways that we find intuitive, that we expected. The third is whether past choice impacts future choices, or at least whether choices are serially correlated. So I think there's a significant marketing literature which has found that customers just tend to purchase the same good over and over. And so while this isn't sort of an economic theory question, this is kind of a fundamental empirical fact that customers, when you see them buy something one time, you are going to make a pretty good guess if you guess that they'll choose the same thing next time. And so to explore that, we change the prompt here and we move over to studying toothpaste. And so what we do here is modify the prompt in 2 ways. So first the options have changed. So we have Colgate and Crest, whitening toothpaste with fluoride. And again, we're changing the price of one of the goods. And then the second way that we change it is we add previously purchased Colgate. Okay. And actually, we're going to do a second version of this prompt, which I'll show you on the next slide, which modifies the second text slightly. So here we're saying this customer bought the Colgate whitening toothpaste last time they shopped for toothpaste. And then as part of just testing our various ideas, we also ran this version, which says the customer says that last time they shopped for toothpaste, they purchased the Colgate whitening toothpaste. So the difference is, in this second version, we're indicating to GPT that the customer is saying that they purchased Colgate last time, whereas in the previous one we say the customer did purchase Colgate last time. And I think we thought of that as being very, very similar, but as I'll show you in a second, we actually got quite different results with these. And so I think it's worth talking about. So here's the first figure, just to kind of level set. Again, here we're plotting Colgate shares now. So the fraction of customers that chose to purchase Colgate as a function of the Colgate price. And as you can see, when we tell GPT that Colgate was purchased last time, all customers, and Colgate is cheaper than Crest, all customers buy Colgate. And then once Colgate is slightly cheaper than Crest, you start to get a downward sloping demand curve again. On the other hand, when we tell GPT that the customer did not purchase Colgate last time, you see what I think is substantially different behavior. So here, you get much lower shares here, and then a dramatic drop once Colgate is more expensive than Crest. So what this indicates is kind of really significant levels of state dependence that I think are kind of, well, I was surprised that it could match this magnitude, and I think that this is kind of similar to what we see in the actual empirical work. And then you do see some differences here now when we say the customer says. So what you see, I mean, it's probably depends on your eye exactly what the difference is, but when we say the customer says that they purchased Colgate, we see a lot smaller drop as a function of the Colgate price in the Colgate shares when it's more expensive. So what to make of that? I think there's different interpretations. Like, is GPT kind of trusting the customer? Does it understand that customers are lying? And of course, here I'm using understanding in this vague sense. It's an LLM. On practitioners, the main point here is that phrasing really matters. You would come up with different quantities, different values for any state dependence parameter that you were to estimate on the left side than you would using the right side. And the only difference is that we happen to phrase it very slightly differently. So that's our state dependence. And I think, although these two are different, both indicate that when a customer has previously purchased Colgate or says that they previously purchased Colgate, they are much more likely to purchase Colgate at every price, which I think is consistent with strong levels of state dependence. And then the last study that we do in this section is studying whether GPT exhibits diminishing marginal utility of consumption. And now I'll warn you before we go into them, this is going to be the one on which GPT fails in our studies, but I have some thoughts that I think about kind of how you might get it to succeed. But it's nice to see that kind of these things don't all work perfectly. So here's how we try to explore this. We try to take a couple of different swings at this. So our first attempt is we still have the randomly selected customer. Their annual income is $70,000. And the customer, we tell it the customer already has some number of units of yogurt at home. Okay, and then we ask it, how much would you pay for one additional unit of yogurt? And the hope and the prediction of economic theory, I think, is that the customer would say, if I don't have any yogurt at home, say I'm willing to spend, I don't know, $3 or $5. And then by the time you get to 10 or 20 units of yogurt at home, they should probably be willing to spend very, very little, I think, the hope. So here's what the results look like when we tell it that there are no units of yogurt at home. And we start with 0 just so we can kind of show you what we're looking at. So here's a standard kind of box plot where we're showing the dark line in the middle is the median. So the median GPT response says, when there's 0 units of yogurt at home, I am willing to pay $3.5 for a unit of yogurt. The dots here are going to be the mean, and then as usual, we have the interquartile rate. So the 25th, 75th percentile range of the units that we explore, you'll see how I think that we sort of call this essentially a failure of our hypothesis. So the medians are more or less flat from 0 up until 10. So telling GPT that it has 10 units of yogurt at home doesn't seem to do anything to the amount that it's willing to pay at the median, at least, for an additional unit. Once you tell it has 20, 50, 100, or 1,000, it goes down, but only by 15 or 20%. If you look at means alone, if you're willing to give us only means, you do see some decrease. It's a little bit smoother, but again, it's really not particularly convincing. And so I think our conclusion here is that, at least so far and in this exercise, GPT doesn't seem to exhibit realistic levels of diminishing marginal utility of consumption. But we thought, okay, maybe the issue with the previous study is that the yogurt we told GPT it had was at home. And so maybe we're picking up on some willingness to store yogurt at home, right? Of course, GPT doesn't actually have a home and it doesn't store any yogurt, but again, we're all kind of, assuming that the text is approximating some kind of underlying preferences of the customers. And so to answer this question, so to try to dig in a little deeper, right? If it was the yogurt at home, then we should be able to get better results if we tell GPT, actually, it's not that you have a stock at home, it's that the customer is sitting at a restaurant. And that's what we're doing in this prompt. They're sitting at a restaurant and they've actually already ordered and consumed some number of glasses of a beverage. And that beverage ranges between soda and wine. And we tried both of those. And our hypothesis, our hope is that by the time we get to saying that GPT has consumed 10 glasses of soda or wine, that its willingness to pay to consume right now another glass should be quite low. But showing you two figures that are structured in the same way as the previous figure, you can see that I think we don't really see anything like that, at least not to the levels that we would expect. So by the time a customer is purchasing has purchased and consumed 10 glasses of wine, for soda, again, you can see small amounts of, diminishing returns, if you'll call that diminishing utility, but not anything super substantial. I will note, however, something that I think is cool, is exciting, is that the y-axis are in units that make sense, or are values that make sense. So, sodas here are $3 and wine is $15, and I don't think it was baked in anywhere that GPT should know that wine at a restaurant should cost $15 or could cost $15, or that soda would cost $2 or $3 or $4. So we think that that's an interesting feature that'll show up later in the presentation. So we still conclude here that GPT doesn't seem to exhibit diminishing marginal utility of consumption. I do have some ideas for how one might be able to elicit it from it, but we don't have any new results on that yet. So to kind of summarize the previous section so far, we think that we have some evidence that GPT corresponds, that its responses conform to some fundamental properties of consumer demand, namely the first three that are listed here. And we don't think the fourth is as successful. So now we'll move on to our second batch of results, which are focused on contextualizing GPT responses. I'm happy to, I'll stop here for any questions if anyone wants to ask anything about the previous sections before I jump into this. Great. Okay. I know I get ahead of myself when we're presenting, virtually. Kind of hard to remember how many people were in the room. So again, feel free to interrupt me as
actually, I have one small question. So, all the experiment you ran, if you have data, actual data, you can do it exactly, right? The same stuff. So I'm trying to, because when people are asking about the usefulness of the GPT, they are trying to see where the GPT can be complementary or the substitution for the human labor. So in this case, I think this kind of obviously it has like a lot of potential. Maybe it's going to develop in the future, but this kind of stuff, I think if you have the data right now, you can just like do it right away with actual coding and maybe some with using actual economic demand. So I think where do you think where do you think it has a value? This kind of stuff, yeah. It's some just broad question.
Yeah, I mean, well, so I think I'll partly punt on that. Yeah, I'll show you more with this kind of contextualization aspect. Oh, you're right. Yeah. You're right that if you had data, and that's a good lead in, that's what I'll use it for. It's so, you're right, if you had data, you could do a lot of the things that we just did with GPT, with that data. I think the question is, how easy is data to come by in the particular circumstance that's of interest? And you can imagine putting GPT-based customers into lots of situations that real customers cannot be put into. And so supposing that the next section works and that we can actually get kind of reasonable empirical quantities, you can ask GPT 1,000 questions in a row and it won't get tired like a customer will, right? Like a person will. You can ask it to engage in thousands of different products, and you can tell it things about the supermarket that it's in, tell it what color things are eventually. So I think that there's, the question is, I'll show you some comparisons later, but I think essentially, if you can actually make this GPT surveying work, you can get a lot more data than you could ever get from real customers.
Okay, yeah, that sounds really interesting. Also, yeah, you can get more response. Also, maybe sometimes you can maybe get the response. Maybe you cannot get from data. Yeah, so maybe the most subtle there, because you guys are using language models, so you can maybe guess more stuff from their responses. Okay, yeah, thank you.
Okay, so let's try and let's see if if we, I said something like, if these surveys work. So now let's try to see how well they did. So we'll move on to trying to get some actual empirical values out of GPT. And we'll start with what we're calling B1 here, which is asking GPT to give us its willingness to pay for products. So this we think of as sort of a softball. This is related to my point about the diminishing marginal utility figures, where GPT seems to understand sort of how much wine should cost and sort of how much soda should cost. But looking at distributions, that would make sense for a customer to be willing to pay. And then, I'll discuss the caveats there and the reasons you might not believe that those are really showing willingness to pay. And then I'll move on to B2, which I think is, to me, much more convincing, which is us focusing on trying to recover the willingness to pay for attributes via a couple of different methods, including actually running a conjoint. So estimating a multinomial logit model and estimating the willingness to pay via the parameters of that model, which I think is kind of the most exciting path forward potentially. So checking the time. Okay. So like I said, the first target is to ask for willingness to pay for products. So here we're describing either the same or a very similar product to what we showed in the kind of initial binary option prompt that we gave very early on. And then what we ask is, what is the maximum price that you'd be willing to pay for this Surface laptop? And then please give please give a single price as your answer. It turns out it really matters kind of how you ask it to respond, and you can end up with some weird things if you misphrase that. And just like we showed you earlier, the responses here are kind of funny. They vary a lot. For example, this fake customer lists its annual income. They say, okay, I need the laptop to be of a reasonable price because I can't afford a super expensive laptop, at $70,000 of annual income. Some of them give ranges, and I think we pull the first value in that range. We've done, I think, both ways. The figures look relatively similar. Yeah, so these are some of the answers that it gives, and we can look at the full distribution. So we gave us a laptop, and we asked what's the willingness to pay for that product, and it's clearly centered around something like $1,000. The median is 1,000, and there's a huge spike right around that number. But there's a significant amount of heterogeneity. So some responses state values as high as $1,400 or $1,500, and others as low as $600 or $700. It's worth noting that a spec very similar to the one that we asked GPT about, I believe, would be listed at some like $1,000 at similar to retail prices, for better or for worse. There are kind of pros and cons of that fact. Now, okay, we gave it this kind of very specific product where it can potentially, I guess, worryingly look up a price, right? So I guess the downside of the fact that I just gave is that maybe the reason that 1,000 is so likely here is because GPT has seen in its trading data the exact product that we just listed paired with $1,000 many times potentially, and so that would kind of be bad for us. So we wanted to try to understand both, if we generalize a little bit, can we still get kind of reasonable prices, right? So like, it would be harder for GPT, I think, to look up a specific price for a more generic product. And so the hope is that at least when we generalize things, we still get willingness to pay that are kind of consistent with the standard types of prices we would see for those products in a store. So what we ask now is, what's the maximum price you'd be willing to pay for one, unit, however defined, of the product? And we vary where the customer is between shopping at the supermarket or sitting at the restaurant, and we vary the product from toothpaste to wine and soda. And I'll just reveal all of these at once because I think it's nice to see. I think this is kind of a thing where you all, the audience, can learn about as much from this as I can. It's kind of all the information I have is right here, and the takeaway that I take from this is something like, okay, it looks like GPT is, giving for things like glasses of soda or a can of soda, it's really only giving a handful of responses with any really significant probability. There's a little bit more variation for a supermarket good like toothpaste, but a glass of wine is similar. And so it's getting the magnitudes right, but it's also tending to choose, $1 or $1.50 or $2. I think it's worth thinking about whether customers would do any better. Whether maybe customers would all name 50-cent intervals for glasses and cans of soda. But I guess I tend to think it would be nice if I could figure out a way to generate more smoother distributions and things like that. But that may be a wishing question.
Hi, James.
Yeah.
Here, I have one question regarding the response. It seems that the willingness to pay seems to be quite bound at the integer number or 1.5 stuff. Is that due to the data where the GPT actually got trained, or is due to some, like it pick up some behavioral biases of people, or?
That's exactly the question. So I would love to know the answer to that. I don't think I can know about the training data at all. I don't know anything, that the public doesn't know. I do think that people, I would be kind of confused if a person I asked on the street, if I asked how much would you pay for a glass of soda, and they said $2.03. That would be an odd response to me. But $2 kind of makes sense, and $2.50 makes sense. So in some ways, it feels like a behavioral response of customers. But I think the bad version of the story is that it's picking up on say posted prices or something, right? Which is not exactly what we're trying to elicit here. In fact, we're trying to learn something about customer preferences. So that is, I think, the limitation of this willingness to pay for products approach, is that it may just be stating prices to us. Looks like there's another question.
Thanks for sharing. I have a question. So I think we can treat ChatGPT as a fancy black box to transfer all the information across internet to answer a question, but it might be like a bias for the information you gather from internet. Like, for example, people who actually post, I pay $2 for a can of soda on internet. People buy expensive laptops, they probably don't share on internet. Do you think that's an issue? Thanks.
Yeah, I think that in theory, that's a huge issue, right? And that certainly, we view this as kind of the very beginning of this type of work. But I think that that's something that should very much be taken into consideration. I think that, partly it's an empirical question. So like we can actually just compare random samples of customers to GPT responses, which is where we're going next. Some ways to imagine feeding some helpful information to help fine tune these to make sure that it's more representative. And I think that that's certainly a direction that we have to think about. Yeah, so I completely agree with the concern. And I think for now, all I can say is let's test it. Let's try it and then see how it aligns with randomly selected samples. Okay. So now let's move on to what I think is the most exciting part of the paper, and certainly it's actually the part of the paper that I did not anticipate we would be successful at. So we kind of all thought we needed to try this. I told my co-authors there's no way it'll work, and they suggested that we try it anyway, and here we are. So I think it's kind of surprising to me that we're here showing this. But the idea is we'd like to move to willing to pay for attributes, basically because unlike prices for products, it's unlikely that there are attribute prices that would show up in GPT's training data. So it's unlikely that someone said, I really wish this toothpaste had fluoride in it because I would be willing to pay $1 more for that. That's a much weirder phrase than I hated this toothpaste and it cost $5, or whatever someone would say. So we think it's much less likely. And to elicit these willingnesses to pay, we take 3 approaches. First, we tried to direct solicitation. So we just ask, here are 2 products. One of them is kind of dominated, one of them is better. How much would you pay for the better product? We try a second method, which is kind of this indirect solicitation method, where we just plot out demand curves and try to calculate kind of a compensating measure. And then the last thing we do is a literal conjoint analysis. So we estimate a multinomial logit and a mixed logit. And what we're going to be able to do is compare to this very recent paper by Fong et al., which is forthcoming in Journal of Marketing Research. They study a real set of customers and their preferences for fluoride in toothpaste and aluminum in deodorant, where fluoride is a positive thing to add to toothpaste and aluminum is in general considered a negative thing to add to deodorant. And they do this really nice work where they real world data. So we think that sort of it's nice for us conjoint, then what we're actually showing is that GPT can match both conjoints and real world data, right? So we're hoping that this is kind of a 2-for-1 in my view. Okay, so let's do direct solicitation. So here's an example of this. So again, we have kind of a customer, they're part of a survey, and we're trying to learn something about their willingness to pay for different attributes of goods. Their annual income is $70,000. And then we just have two options. It's the same toothpaste. They're both whitening toothpaste sold by Colgate. One has fluoride and one doesn't. And then we ask the customer, how much more would you be willing to pay for option 2 than for option 1? And then we ask it to give us a dollar amount that it'd be willing to pay. And very simply, we get kind of a sort of reasonable looking distribution to me. No one says I would be willing to pay negative amounts because I hate fluoride, which would be kind of surprising. And we get a median of about $1. And now I'll give you some context for that coming forward, but just for now, remember that our median here is $1. So when we ask it directly, it can give us a number, and $1 doesn't seem particularly crazy to me. Now I'll dive into the indirect solicitation. So for this, we're going to do something kind of like what we did with state dependence, where we'll plot kind of 2 different demand curves. So we'll estimate demand for Colgate with and without fluoride using the kind of same tools that we did earlier. And we'll then compare the shape of those demand curves and derive willingness to pay for fluoride by taking a horizontal difference. Okay, so I'll show you the result of that. So here, what we're plotting is in red, this top line, we have the demand for Colgate as a function of the Colgate price when Colgate does have fluoride. And we're doing the same thing that we did earlier, where we I believe have a reference good of Crest, which is at $4. And then second, in blue, we have the demand for Colgate without fluoride. And then the idea is, you know, one way to get at a sort of implied willingness to pay for GPT have to change the price with fluoride, reduce the price, or excuse me, raise the price of the Colgate with fluoride in order to get the same level of demand that I got from Colgate when it didn't have fluoride. And so we can take horizontal differences between the demand curves. And for example, if we take that at this kind of middle range 3, we get something which is pretty similar to the direct solicitation approach. We get about $1.19. So we previously got $1, and now when we do this kind of demand curve comparison, we get $1.19. Now, this value will depend kind of where you take that difference. So it gets bigger as you go to the left and smaller as you go to the right. And so I think there's reasons to think that this is not the ideal way to do it. So I'll move to our last approach, which is the most exciting to me, which is recovering preferences via conjoint. So this is very close to my heart as an IO economist, and it's very fun to be able to estimate a mixed logit on data that didn't really come from real consumers. So, you know, the idea is relatively simple. So we're going to generate a bunch of responses, just like we have for the other experiments. But instead of plotting demand curves, we're just going to treat those responses as if they came from real customers who were choosing between 2 different options. And then we're going to reformulate, you know, shape that data for mlogit in R, you know, kind of the standard thing that everyone who estimates multinomial logits uses. And we're just going to estimate preferences. And this is sort of getting at part of the question that Sanggu raised, which is like, what can you do with GPT that you can't do with real customers? Well, there's a lot of work in human-based conjoints that's kind of focused on how do I actually design the survey instrument that I'm going to hand over to customers, because I have to worry about customer attention. You know, do they actually even understand the question? Can they answer 100 questions in a row? Which ones are hard for them and which ones are easy? Maybe I only need to do 10 questions. You know, there's a lot of complications there. To the contrary, in our case, we can just throw everything at the wall. With GPT. So we just took for toothpaste, where we combined with and without fluoride and at different prices, and we just asked GPT each of those questions hundreds of times, and then we have this big data set of 10,800 responses that we can do our econometrics on. So there's kind of a speed benefit there, and also we had to think a lot less about how to generate those choice sets than you would have to if you were actually interviewing real customers. Okay, so here's the type of conjoint prompt that we give. So very similar to the types of prompts before. The difference here now is that we have Colgate whitening toothpaste, and then we either say with or without fluoride, and then we have a price for Colgate. And then, unlike previous prompts, we are also going to control whether the alternative Crest has fluoride or not, and what the price of the Crest is. So we're gonna just vary between 99 cents, $1.99, and $2.99. This is following that Fong et al. Paper that I mentioned before. And then we'll also vary fluoride to be with and without for both products. The first thing I want to show you is just, this is not a loaded. This is just taking dummy variables for the choice of GPT being Colgate and regressing this on the covariates that we have included in the conjoint. So here what we're showing is that raising the price of Crest increases the likelihood that the customer chooses Colgate. Increasing the price of Colgate decreases the likelihood that the customer chooses Colgate. And then there are sort of product dummies. And in this case, you actually see that the Colgate dummy is actually larger than the Crest dummy. And so our point here is, first of all, that the signs flip as they should on the right-hand side, but broadly that sort of choice probabilities fundamentally are correlated in the ways that we expect. So not only is our own price effects the direction we should expect, but cross-price effects seem to be the direction we should expect. And the dummies are kind of reasonable magnitudes, at least relative to each other. So we think that's exciting. And then we can go to kind of the headline version of this. So if we convert, instead of running a binary choice, logit model in column 1, and then a mixed logit model in column 2, we find what I think are really nice, reasonable estimates. So we get a price coefficient of -0.48 in both the not mixed and mixed logits. We get positive values for fluoride, and we get Colgate and Crest dummies that are both negative, but of course these are all relative to the outside options, so the signs don't matter. The point is that Crest is preferred to Colgate in this context. And then when we allow for multinomial, when we introduce a mixing distribution, so we estimate a mixed logit, we do find kind of significant heterogeneity in the preferences for fluoride and for price. Now, I'll note for kind of econometricians in the room, these standard errors are all wrong, right? There's no, the data generating process here, certainly these are not IIT customers. This is a totally new ball game when it comes to thinking about inference. And so I think that's something that kind of the literature will have to deal with and we will have to deal with. But I just wanted to make that caveat. But in general, the signs make a lot of sense. And when it comes to magnitude, you'll remember that before, when we did our direct and indirect methods, we found that the willingness to pay for fluoride was something like $1 or $1.20. Now, when we use a conjoint, we find that the implied willingness to pay by dividing the fluoride coefficient by the absolute value of the price coefficient, which is the standard approach in IO and marketing, et cetera, we get a value of $3.40 for fluoride. And what really just I love, this is obviously my favorite result in the paper, because Fong et al. Found with real people that their estimate of the willingness to pay for fluoride was $3.27. So of course, those aren't perfect. And if you look in the paper, you'll see that our results for aluminum and deodorant are significantly more different than their estimates were from real customers with aluminum. But I think this is really encouraging that our paper with very little prompt engineering was able to get kind of close so quickly, and with other things that you know kind of indicate this model seems to be. Okay, so like I said, you know, we do a little bit in the paper with aluminum, and all that I'll show you here is that when we plot a demand curve for deodorant with aluminum, it is higher. Excuse me, without aluminum, it's higher at every price than the demand curve for deodorant with aluminum. So GPT is correctly able to assign the fact to demonstrate that customers on average have negative willingness to pay for aluminum. So there are sort of like health risks that some I think have identified with aluminum deodorant. So the nice thing is that it's not that we always find positive willingness to pay. We actually have a case where aluminum is kind of, there's distaste for aluminum. So I think I just have a few minutes, so I'll you know, start moving to wrapping up. I think when we think about comparing GPT to real world conjoints, I think that the pros here, if it works, are just very apparent to me, at least. We can combine any number of configurations of products that are real or not real and ask GPT and evaluate them. We could run 50 conjoints, you know, relatively easily. And from a cost perspective, I mean, it's amazing. It takes us $3 and about half an hour to run a single hour conjoint, which, as we noted, produced the same estimates or very similar estimates for the willingness to pay for fluoride as this paper, which I'm guessing paid multiple dollars per participant. And so if you want thousands of participants, we're talking about, you know, multiple orders of magnitude difference in cost, and certainly differences in time. And that certainly matters if you start to think about, you know, what if I want to run 100 conjoints, right? Or if I'm a regular, you know, customer of conjoint businesses. So I think that there are a lot of potential benefits here. I'm going to go a little bit further. So what I think we did in the paper is we showed that you can use GPT as a sort of get out of it are not crazy. They seem of economic theory, like I mentioned, and they also produce estimates that you know, of willingness to pay that are also kind of very consistent with empirical facts, either real prices that we see in the data or the results of surveys on real humans. So I think the next question is kind of, what does that mean? I think the hope is that at minimum, it means that you can think of GPT as a simulator of customer choice. And that can mean you just need some data to test your, you know, empirical marketing or empirical IO code. And so you can generate some choice data from GPT, and it'll at least be well behaved enough that you can probably get model estimates. So you can treat it as a simulator. But I think it's much more than that. And so if you think about, you know, if you're really thinking about trying to make this an empirical tool, the great thing about it is that you can provide GPT with a lot of additional knowledge. So you can add kind of pages and pages of additional context describing the type of customer that you care about, the type of sampling that you've done. You can sample incomes, for example, pulling from a nationally representative income distribution. There's all kinds of choices that you have here. And what we hope is that, kind of, as LLMs advance, we expect that both the LLMs itself will become more useful, and also people will learn better about how to prompt them and how to provide context in ways that will make them more useful to researchers. Of course, there are certainly concerns. So one concern was raised earlier, which is that these responses may not be representative in many cases. And so we have to think about how to use additional tooling to either understand when GPT will not be representative or make it representative. There's also issues with hallucination, which we have to really think about. And of course, there's a huge concern to think about ethical concerns. So, you know, there's I think a lot of incentives to produce market research using GPT And given that these kind of seem reasonable on their face, it's worth where the market research. But I think there's a lot of really exciting things that can be done in this direction. And our hope is that we can move to things like exploring our approach for evaluating new products, as was mentioned very earlier, studying various types of biases you might see in customers and exploring whether those are apparent in GPT, and a handful of other things that I'll skip in the interest of time. To sum up, we have a slide. We have what GPT would say if you asked it to generate a final slide about using GPT for market research, and you can read it. I sort of don't even remember what it says, but I love that it makes something that's pretty coherent. I'll read the last bullet. As GPT continues, models continue to evolve and improve, we encourage businesses to explore their use in market research and stay abreast of the latest developments. It's really fantastic. So with that, I'll stop. I think we're kind of right on time, and thanks very much for everyone who's in the audience. I'm happy to take questions and here or offline. Thanks.
Okay, thank you very much, James.